Hello everyone, my name is Rizwan and welcome to the Nowhere. So today we will be solving problem 566 from the Leetcode problem sheet, which is reshape the matrix. What we have to do is we are given as an input, will be given as a matrix having certain number of columns or certain number of rows. And then what we have to do is we have to turn it into a different matrix with given rows and columns, which are C, which is here, C's and R. So R represents the rows and C represents the column. So what is interesting is in here is that the number of elements in both the after transformation. All right. So the number of element in both the matrices is going to remain same. So for example, in the input matrix, that is 1, 2, and 3 and 4, the number of columns are 2, which is 0 and 1, and also the number of rows is 2, so 0 and 1. So after transforming it into a flat matrix, which is there is only one row and there are 4 columns, so the number of elements are going to be same. So in the first matrix, the number of elements are 1, 2, 3, and 4, and also in the transformed matrix, the number of elements are going to remain the same, which is 1, 2, 3, and 4. So if that is not the case, then what we have to do, we have to return the original matrix. We have to return this matrix because there is no way we can transform it. It is going to need some, it is going to violate the conditions of the problem. All right, so we will be transforming it here. This is the code for the this particular problem. And okay, first of all, we will begin with initiating the new matrix. This matrix we are going to return at the end, and this will be our new matrix. All right. So M is equal to the number length of the matrix which is given. All right. M is equal to the number of rows of a given matrix, and n will be the number of columns of the given matrix, which is mat. All right, yeah. So also we have to given the condition as we discussed before that if the number of elements in the first matrix in the given matrix is not equal to the number of elements uh, in the in the new matrix, right? So how we are going to check? Simply we are going to do m into n, and for the new matrix, we will check the number of elements by multiplying r into c. So which is these are both rows and columns. For this one is for number of elements of the given matrix, and this one is the number of elements in the transformed matrix. So if they are not the same, then simply we are going to return the original matrix. And okay, then we will go to the work here. So first of all, what we'll do is we'll flatten this matrix. Every matrix we are going to flatten it. What I mean by flatten is that we will every matrix that we will get, any matrix, there was going to be only one row of that matrix, right? So we'll convert it into a matrix of only one row. So how are we going to do that? We will simply create a flat which will be equal to num for row in mat for num in row. All right, so simply it will flat will be equal to num. So what is num? So for row in matrix, in matrix, first of all we'll check for a row in matrix, and then we will check for no in num in row. All right. So first of all, to further discuss it, we are going to look for row in the matrix. All right. uh, and then we will look for number inside a row. So this one is going to be our first row. One second, 1 second. Okay, so this one will be our row 1. This one will be our row 2, and these 1, 2 will act as nums of row 1. Okay, so the is inside R is inside the matrix, and inside the rows are nums. All right. So this is how it works. So this one will act as row, 1 comma 2, whatever the number are going to be inside the matrix. So this one will act as a row, or here it is going to act as a row, and the whole is going to act as a matrix. So I hope you understood this point. So the num, or you can do it separately by appending, simply appending, creating a empty flat matrix, and then appending inside a flat matrix from simply iterating, right? So you can also do that, but I think this one is a little bit easy. That's how I did it. So moving forward, what we will do from there, we are simply going to approach this here. Okay, we will for I in range I in we are going to iterate I in range R, and we will append new matrix, which we have initiated here, the first in the start. And then what we'll do is we are going to append flat. We will also be using a concept of slicing. All right. Okay. What we'll do here is, okay, flat has I into C to I plus 1 into C. So here I into C. So we have, if we take this example here, so R is equal to 1 and C is equal to 4. All right, this is our example given. So what will be our I, first of all, will be in range R. So it will only one iteration is possible. All right. So which will be 0, which will be for 0. I will only be equal to 0. Only because only one iteration is possible, because R is 1 and 1 is excluding. So before 1 there is 0. So only one iteration is possible here. Okay, what we are going to append is flat I into C. So I is equal to 0. I is equal to 0. And C is equal to, as we know, is equal to 4. So what we have to do is I 0 into C is equal to 0 to I plus 1 into C. So I plus 1 is equal to 1. 0, I is equal to 0. So 0 plus 1 is equal to 0 into C. So C is equal to 4. 1 into 4 will be equal to 4. So we have to append, new mat. Okay, we have from flat 0 to 4. Okay, what is 0? 0, 1, 2, 3. Right? So we know that this 4 is excluding, it's not including. And in actuality, there is only going to be all the elements from 0 to 3 will be appended. All right. So 1, 2, 3, 4 will be appended inside the new matrix. So this is how we are going to, and then we will return the new matrix. So we will actually get this answer here. New matrix will get. Similarly for this also. Similarly for this matrix, we can use the same concept in this matrix. What we will get here is what is the R? R is equal to 2. R is equal to 2. And C is equal to 4. Okay, so flat will be I to C, and so flat will be 1, 2, 3, 4, as we discussed. 1, 2, 3, and 4. All right, this is going to be our flat matrix. And flat will be here for iteration R is equal to 2. Here it will be R will be equal to 2. All right. And C is equal to 4. Yeah. So C, as you can see here, C is equal to 4, and it's not adding up because the elements are different, as you can see. So how many elements are there is equal to M into N. So M is equal to 2 into 2 is equal to 4. Total number of elements M into N will be equal to 4. So R into C must be also equal to 4, right? But we can see here R is equal to 2 and C is equal to 4. So the total number of elements, 4 into 2 is equal to 8. The total number of elements are not adding, so it will return mad. All right. So it will going to return the original matrix. So I hope I was able to make you understand this problem. If you like the video, please do like, share, and subscribe this channel. Also, if you're watching this on Facebook, don't forget to follow the page. Thank you.